All right, Rad Nation. Today we're talking about inverse square law. Specifically, if someone gives you a problem like this, where they say you have a given MAS, you have a given distance, and then we're going to change the distance from your X-ray tube to your image receptor, how's that change the MAS? We're going to cover why there's a difference in MAS that you're going to need in order to compensate for that change in what we call source to image distance. Stick around to the end. You're going to find out the answer to this question as well as why that's the answer. So starting off with the theory, don't worry, it's not going to be detailed, no big equations, just one little one. You start off with an X-ray tube. The X-rays are coming out from a relatively small area that we call the focal spot. So those X-rays are coming out in a cone shape. So you can think of it like this. There's a relatively large cone as you're getting further away, and as you're closer to the X-ray tube, that cone is relatively smaller. So we call that divergent. When you're leaving, it's diverging, or the X-rays are spreading apart. So if you think about having a plane right here, imagine the X-rays are traveling through vacuum, so you're not losing any due to attenuation. Right here, if you had a plane, or right here, if you had a plane, that's actually the same number of X-rays. So what's happening here? Imagine we talk about the intensity of X-rays that we're seeing here. The intensity is I at a distance R. And then if we move further away, what's going to happen? Actually, we have the same size detector or image receptor that we're using here, and we move further away. And what's happening is now we have I divided by 4 if we're 2 times further away. Then imagine we go another distance away. So now we have 3R. So what's it going to be? It's actually going to be I divided by 9. So what's the pattern that we're seeing here? The pattern actually is the intensity is proportional to the inverse of the square of the SID, or the distance R, we've labeled it here. Another picture that we're going to show here, just a kind of different angle of looking at the same thing. So imagine the X-rays are spreading out, and in one given area right here, you have 9 X-rays that you're seeing here. And then those same X-rays, they're spreading out here, and they're going to spread out. So here you're 2R away, and then here you're 3R away. And by the time you're 3R away, you can see that there's only one X-ray that I've drawn here. It's now hitting each of these little areas, and those areas are the same. We're just drawing them here so that you can get the idea that here there's a much higher intensity. So if the intensity is I here, it's I over 4 here, and it's I over 9 here. The intensity is inversely proportional to R squared, or the SID squared, the distance from the X-ray tube to your image receptor. So this is called the inverse square law, 1 over R squared. Then the idea is a lot of times we want to actually have the exposure be the same. So we've really made a good exposure. We know this technique works well. The density is good on film. The noise is good on our CR or our DR system. And now we'd like to change the SID, but we want to have the intensity be the same that our image receptor sees. So we'll have a link down below to what you need to do to change the time or the MAS if you're changing any of the exposure factors. But specifically for the one that we're talking about here, for the SID, the equation you need to know is that if the MAS new equals the SID new divided by the SID, and these are squared. Just because we talked about, we have an inverse square law. So as we're changing the MAS from our original MAS to an MAS new, we need to compensate for this. And we're going to see, the idea is that if you're moving further away, you're going to need to have a higher MAS so that you get the same number of X-rays hitting the detector. And if you're closer, you're going to need less MAS. And We can also, since these two things are squared here, what we can do is we can put them in a parentheses, so we can take the ratio first and then we can take the square. So a lot of times that'll simplify the math a little bit. You can cancel out zeros. We can then make a table. So this is a relatively detailed table. Again, I'm sorry, I live in the United States. We use these backwards units, but they're still used in the clinic as well. When we're talking about things, we're a lot of times talking about these units in inches. The table would be relatively the same in centimeters. Drop me a note down below if you want to see this in centimeters, and we can make it in centimeters as well. But the idea here is that 40 inches is a relatively standard case. And on the top, we have our original SID. And then over here, we have our new SID. So what we've done here is just taken that ratio and then we've basically rounded it so that if you're in the clinic and you need something quick, you could potentially look at a table like this. You can also make a table like this for any factors that you're doing relatively often, depending on if you're in a mobile scenario. That's where you're more often going to be changing these SIDs on the fly. The other table we have here for you guys is what factor would you need to multiply the MAS by if you have this given change in SID. And in this case, we're considering just the case of 40 inches, but we're considering like a larger region, so larger steps. And you can look at the idea here is if you look at 40, it's going to be 1 because that's our reference here. And then if you look at another given number here, you're going to see what the essential difference would be if you went from 40 inches to 60 inches. You would need to multiply by 2.25 or roughly 2 if you want to have just a simple number in your head. We're going to go through just a couple sample questions now. You can get the idea of how to do these problems because these are going to be common types of problems that you might see on a registry type exam. So imagine your MAS was 22 1/4 and your distance was 40 inches. So the SID is 40 inches, and then we're going to change it to 80 inches. So we're moving much further away. So since we're moving further away, we need to think about, are we going to need to be increasing or decreasing the MAS? Because we need more X-rays hitting the detector because we're moving further away. So we are going to have to increase our MAS. So let's use that check when we're done to make sure we did it the right way. In this case, we have 80 divided by 40. So if you cancel out those zeros, then you have 8 divided by 4. That's just 2. So then we are going to raise that to the power 2. So 2 to the power 2 is just 2 times 2, right? So that's just 4. So that's going to be our factor. So we're going to multiply our original MAS was 22 1/4. We're multiplying that by 4. And another sample one is, what if you start with 100 MAS and you started at 60 inches? Again, I apologize for the units, but the principle applies the same. You can plug in your numbers. Even if they're centimeters, it's going to be the same idea here. We do the same thing. We take the SID new divided by the SID, and then we're going to square that. And we have our new SID is 40. Our old SID was 60. So we can cancel out those zeros. So if you have 2/3 squared, that's 2 squared is 4 on the top and 3 squared is 9 on the bottom. So 4 divided by 9. So that's close to 4 divided by 10, right? So if we need to do some simple estimation, we'd say it's close to 4 divided by 10, or it's close to 0.4. If we actually put in our calculator, we'll get 0.44. So that's one way we can do it. The other way we could do it is we could look here at 60, and if we start with 60, and then we see we're going to change and we're going to go down to 40, we could look in our table and it'll tell us also it's 0.4. So either way we do it, we're going to get a number that's around 0.4. If we plug into our calculator, we got 0.44. So 0.44 times 100 that's going to be 44 MAS. So we started with 100 MAS. We moved from 60 to 40. So our SID got smaller. So that makes sense because now there's going to be relatively more X-rays hitting our detector because we move closer. So we can turn the MA down, or we can turn the time down in order to have the same intensity that's actually hitting the detector. Congratulations, now you know the inverse square law, you know how it works. This is just the tip of the iceberg though, guys. We have several other factors that are really important in X-ray imaging, so make sure to check out the video we have on exposure factors in X-ray imaging so you can make sure to get all of them internalized, be able to write them down, and you'll be able to solve any of this X-ray math once you've got that mastered.